Today's notes are all about equivalent ratios. So I'm personally on page 15 in my notebook, and as long as you're ready with your notebook and a pencil, we can dive right in. So we're going to title this page Equivalent Ratios. E-Q-U-I-V-A-L-E-N-T, equivalent, and ratios. Okay, I'm going to underline that as my title. So today we are going to review what an equivalent ratio is and how to find them, especially when they have a missing piece or pieces. So we are first going to define the word equivalent. So I'm just going to put an arrow below equivalent. Equivalent means equal. Now, even though a ratio might look different, if it's worth an equal amount or the value is still the same, we call them equivalent. And if you remember from yesterday's lesson, ratios are comparisons. So I wrote comparisons there. Let's do 6/8 or 6/8. Now, if you're thinking about this as a ratio, that means I have maybe 6 objects out of 8 objects. So I'm going to maybe make 6 circles, 1, 2, 3, and 3 below that. 1, 2, 3. 6 circles. Now, if I have a total of 8 objects, that means I need 2 more objects that aren't circles. So maybe I'm going to do 2 squares. So what I've done right here is I've created a ratio that's a part to a whole. Part of my group is 6 circles, and the whole group is 8 objects. Now, if we want to have an equivalent ratio, just like when we are simplifying fractions or changing to an equivalent fraction, whatever you do to one number, you have to do to the other. So for example, if I want to come up with an equivalent ratio that has smaller numbers, I'm going to divide the 6 and the 8 by the same number. Then I can divide by 2. Now, let's see what happens to my ratio. 6 divided by 2 on the top is 3. 8 divided by 2 on the bottom is 4. Now let's show in my picture that 6/8 or 6 to 8 is the same as 3 to 4. So what I'm going to do is I am going to cut these in half. So I am going to take my picture and I'm going to draw a little line down the middle. I've cut it in half, so I've divided it by 2. Now, if we notice, the original picture had 6 circles and 2 squares, but if I cut it in half, we have 3 circles and 1 square. So the relationship is the same. 3 circles, so here's our 3, out of 4 total objects. Here's our 4. The relationship was the same. I just used half of my picture. 6/8. So we're going to try this again. Now, instead of making my numbers smaller by dividing, we can make the numbers bigger by multiplying. So if I'm thinking of this as a recipe, if I multiply my 6 by something, let's triple that. 6 times 3. Now, to make the recipe taste the same or to keep the ratio equivalent, we need to do the same thing with the 8. So we're going to do 8 times 3. Okay, let's see what my equivalent ratio would be. 6 times 3 is 18. 8 times 3 is 24. Now, because we did the same to both pieces, I know that this ratio is the same or equivalent. Let's try this with another type of ratio. So we've done fraction form. Let's do colon form. Okay, let's give a ratio. Let's say I have 2 cups of flour and 3 cups of sugar. So 2 to 3 is my ratio. 2 cups of flour, 3 cups of sugar. Now, if I want an equivalent ratio, maybe below that, I can get another colon ready. And I want to get from each number to a new number. Remember, just like up here, whatever you do to one part of the ratio, you have to do the same thing to the other to keep it equivalent. Let's multiply by 8 times 8 on both sides. So over here, we have 2 cups of flour times 8. We're going to make 8 recipes. 2 times 8 is 16 cups of flour. Now, we have to do 8 times the sugar as well to make sure it tastes right. 8 times 3 is 24. So if I needed to make 8 recipes, I'd need a total of 16 cups flour and 24 cups sugar. Okay, let's try one final way, and that's word form. So let's do, we'll do 4, 2, 6. If I take 4 hours to make 6 projects, let's see what would happen if I had a different amount of time. So I'm going to get my word 2 ready. I'm going to get some arrows. Okay, so if I didn't have 4 hours, if I only had 2 hours, let's figure out how many projects I could make. So how could I get from a 4 down to a 2? Well, I could divide it by 2. Now, if I divided my time by 2, that means I'm going to have to do the same to my projects. I'm going to divide my projects by 2 to figure out how many I could make. 6 divided by 2 means I could only make 3 projects. So if it took 4 hours to make 6 projects, if I only had 2 hours, I would only get to make 3 projects. Okay, the final part of our notes today is what we can do when we have some missing pieces. So let's do a fraction form. So I'm going to get 2 fraction lines ready with an equal sign. And I'm going to get a ratio. So I'm going to do 3 and 7, and I'm going to do a 12 on top over here, and then there's a box because I don't know what that means. Now, in real life, this could mean that it costs $3 for 7 books. If I spend $12, how many books could I have? So here's what I'm going to do. I always like to draw arrows, and I like my arrow to land in the blank or empty missing space. So I'm going to draw an arrow from a 7 to this mystery box. I'm going to have to do something to 7 to get my mystery number. Now I'm going to draw an arrow in the same direction. So I'm going to start over here at the 3, and I'm going to land at the 12. See how my arrows go in the same direction. Now, all I need to do is figure out what operation I use to get from a 3 to a 12, and then I'm going to do the same operation for my 7. You only have 2 options here. You can only multiply or divide. So let's draw those off to the side. Those are our options. We're not using addition or subtraction because multiplying and dividing is what makes things equal. When we think about dividing, it's equal groups, or multiplying, we have the same size groups over and over. So how do I get from 3 to 12 using multiplication or division? Well, since it got bigger, I know multiplying makes things bigger. So I'm going to put multiply here. 3 times what equals 12? Well, I know my math facts say that 3 times 4 equals 12. Now, if I did 3 times 4 up top, I need to do 7 times 4 on the bottom to keep it equivalent. 7 times 4 is 28. So if I spent $12 at the store, I'd be able to buy 28 books. Let's try one more of these. Okay. I like fractions, although it would work with colons. So let me show you a colon example. So if I have 2 colons, I'm going to set up some equivalent ratios. So if I have maybe a 5 and a 9, and then I'm going to put a box over here, and I'm going to put a 15 over here. Okay, so what this means in real life, let's do maybe a recipe. So if a recipe calls for 5 cups of sugar and 9 cups of chocolate chips, I'm making a bunch more recipes. So instead of 5 cups of sugar, I actually want to use 15. How many cups of chocolate chips would I need to make my recipe taste the same? So again, I'm going to draw some arrows. I like my arrow to always land in the missing piece. So I'm going to draw an arrow from this 9 down to this missing piece. So I'm going to draw the arrow in the same direction, up from the 5, down to the 15. See, my arrows go in the same direction. So I'm going to look at the 5 and the 15 to get my operation. How did I get from a 5 to a 15? Well, I multiplied by 3. If I multiply by 3 on the other side, it's going to keep things equivalent. 9 times 3 is 27. So I need 27 cups of chocolate chips in order for my recipe to taste the same. We're going to try one final one in word form. Okay, so we have some words that say 2. Let's come up with a ratio. So I'm going to do an 18 and a 21, and I'm going to go a 6 above the 18, and we have a missing spot there. Okay, so if I have a ratio 6 to something is equivalent to 18 to 21, let's figure out what that something would be. So I like to draw my arrows that land in the empty spaces. So I'm going to draw an arrow and land up here in this missing space. So I'm going to draw an arrow from the 18 up to the 6. So I'm going to look at 18 and 6 to figure out what's happening. How do I get from an 18 to a 6 using a math fact? Well, since it got smaller, I know it's a division fact. So I'm going to get my division sign ready. 18 divided by 3 is what gets me to 6. So if I divide it by 3 on that side, I need to divide by 3 on the other side. And I know that 21 divided by 3 is 7. So this tells me that the ratio 18 to 21 is equivalent to 6 to 7. What I really want us to remember today is that equivalent ratios, although the numbers are different, they are equivalent or equal to each other. And a great way to remember this is whatever you do to one number, you do to the other number. So here, when we multiplied one number by 4, we multiplied the other number by 4. It's just like when we are simplifying fractions. Whatever you do to one, you do equally to the other.